Welcome to This Explainer. Today, we're completely breaking down ClickHouse Cloud. We're going to dive deep into its fully stateless architecture and explore exactly how it's transforming the whole landscape of real-time analytics. Look, if you've been working with big data for a while, you already know that balancing scale, speed, and cost, well, it's a constant battle, right? So today, we're popping the hood to see how modern cloud architectures are actually attempting to solve this. So think about this for a second. Historically, databases have been super tightly bound to their underlying storage. But what if your database didn't need local disks at all? None. We're going to see how a fully stateless compute layer, where compute nodes literally don't store anything locally, meaning no syncing and no warm-up time, basically changes everything you know about database scaling. It's this massive shift from your traditional shared nothing setup to a highly elastic shared everything architecture. Here's the roadmap for this explainer. We'll start by meeting ClickHouse Cloud, then get into the stateless architecture explained. After that, we'll compare cloud versus self-hosted, check out some performance and cost benchmarks, run through essential best practices, and wrap up with uptime guarantees and our conclusion. All right, section 1, let's meet ClickHouse Cloud. So, ClickHouse Cloud is essentially a fully managed service, and it's built by the original creators of the open-source ClickHouse database. By completely separating storage and compute, it's designed from the ground up to eliminate that heavy infrastructure maintenance. Because it handles the sizing, the scaling, and all that operational overhead for you, your team can focus entirely on actually building value instead of just, managing hardware. It even brings in tools like ClickPipes for managed data ingestion. But honestly, the real magic is how they achieve all of this under the hood. Which brings us to Section 2, the stateless architecture explained. It all comes down to something called the shared merge tree. This is a shared everything table engine that entirely separates your data storage from your compute. Basically, all your durable data is stored directly in object storage, and get this, the replicas don't even communicate directly with each other. Think of it like a massive shared kitchen where any chef can just walk in and start cooking without needing to bring their own ingredients. They just grab whatever they need right from the shared pantry. That is exactly what enables this incredible elasticity without those traditional, annoying wait times for data to sync across nodes. And because you don't have local disks tying things down, the new data definition language, or DDL, object lifecycle, explicitly tracks metadata across 4 distinct stages. First, intention to create. Then, successfully created. Next is drop scheduled, which, by the way, offers this brilliant grace period where an object is just soft deleted, meaning it can actually be undropped if you make a mistake. And finally, drop in progress. This staged model absolutely guarantees that metadata is never left behind, it avoids the risk of orphaned files, and it makes reliable background deletion possible without ever stalling your compute nodes. So how does this actually translate to real serverless scaling? Well, there are 3 main auto-scaling components working constantly behind the scenes. You've got the idler, which suspends pods that aren't actively receiving queries. Then there's the scaler, which ensures there's enough pod capacity up to whatever limit you specified. And finally, the proxies. These sit right in front, buffering incoming requests and notifying the scaler if a system has been scaled down to 0. These 3 components work together seamlessly to literally scale your compute all the way to 0 when idle. That saves you significant resources when the database just isn't being actively queried. Moving on to Section 3, Cloud versus Self-Hosted. The absolutely crucial point to understand here is the operational reality. When you self-host, your to-do list is massive. You're looking at server provisioning, ClickHouse upgrades, configuration tuning, security patching, and managing all your own backups, which, let's be honest, usually break right when you're about to log off for the weekend, right? In contrast, cloud operations narrow your focus way down to just schema management, query optimization, user management, and cost monitoring. The operational overhead shrinks so dramatically that it completely eliminates the need for infrastructure patching and that intense, stressful capacity planning. Okay, Section 4. Let's look at some performance and cost benchmarks. Based on a really detailed analysis by the open-source observability platform OneUptime, the cloud version drastically cuts your total cost of ownership. Now sure, compute costs might actually look a bit higher on the cloud side because of the auto-scaling, but the massive game-changing difference is in DevOps time. A self-hosted 3-node cluster, that can run you up to $10,000 a month simply because it requires roughly half of a full-time engineer's attention just to keep it running. The cloud version shrinks that DevOps requirement all the way down to just 0.1 of a full-time equivalent. So overall, you're looking at cutting your total costs nearly in half just by moving to the cloud. And let's just compare this to other competitors in the real-time analytics space like Snowflake. If you really want to hit maximum query performance in Snowflake, you generally need their enterprise tier to unlock features like the search optimization service and materialized views. Doing that bumps the cost up to $3 per credit, and on top of that, you incur additional background maintenance costs for those materialized views. It's just a completely different pricing paradigm that you absolutely have to factor in when you're evaluating your real-time analytics stack.
Next up, Section 5, Essential Best Practices.
Okay, we need to bust a vital misconception right now. If you're coming over from a traditional relational database, you probably expect a primary key to strictly enforce row uniqueness, right? Well, in ClickHouse, that is absolutely not the case. Primary keys here simply define how data is sorted on the disk. This makes queries incredibly fast because it allows the engine to just skip massive blocks of irrelevant data. But they do not, I repeat, do not guarantee uniqueness per row. Knowing this little fact will completely change how you approach your data modeling here. Let's talk about materialized views. You basically have two distinct flavors of materialized views in ClickHouse, and choosing the right one for your use case is absolutely critical. First, you have refreshable views. These act kind of like your traditional data warehouse. They recompute on a set schedule, and they're fantastic for complex transformations. But the catch is, you have to manage bookmarks and backfills yourself. On the flip side, you've got incremental views, which are much more unique. These actually act as insert triggers. They run a select statement on every single incoming batch of data, which makes them insanely efficient for continuously maintaining your aggregations right as the data arrives. So, with all this going on, how do you maintain visibility? The answer is system tables. Instead of just guessing where your bottlenecks are, you can query these built-in system tables using standard SQL. For example, the system.query_log table captures the complete lifecycle of literally every query, giving you exact timing and resource usage down to the individual CPU cycles and memory used. And then you have system.parts, which helps you understand exactly how your data is being merged behind the scenes. Seriously, this is how you definitively find out if a query bottleneck is bound by CPU, I/O, or network. All right, bring us home with Section 6, Uptime Guarantees and Conclusion. Because this whole system is completely decoupled and stateless, ClickHouse Cloud backs their high availability configuration, which just means having at least 2 replicas running with very strict service level agreement targets. If their uptime dips below 99.9% in a given month, you actually begin accruing service credits. And that scales all the way up to a 25% credit if the monthly uptime were to drop below 95%. This is huge because it puts the financial accountability directly onto the managed service itself. Just as the one-uptime analysis concludes, deciding between these two paths really just comes down to the shape of your team. ClickHouse Cloud is the clear choice for most organizations because it frees you up to focus on your data, not managing servers. Self-hosted is definitely still viable, but realistically, it's only for large enterprises that have dedicated infrastructure teams, massive scale exceeding 50 terabytes, and super predictable growth curves. I'm going to leave you with this final, provocative thought to consider today. Take a hard look at your current infrastructure. Is your data warehouse truly stateless? Or are you still out there paying for idle disks that are just sitting around waiting for a query? With these new shared everything architectures and compute totally decoupled from storage, it might just be time to rethink your real-time analytics stack. Seriously, explore what true serverless elasticity can do for your organization's budget and speed. Thanks for joining me on this explainer today, and as always, keep questioning how your data is built.